Welcome. Today we're diving into something truly fascinating in the world of regenerative medicine. We're going to explore a new frontier that's trying to get inside one of the most heavily guarded places in our entire body, the brain.
Hello, this content is brought to you by the Japan Regenerative Medicine Attend Center.
So let's start with a really interesting question. The brain has this incredible defense system, right? A fortress to keep it safe. But what happens when that very same fortress keeps out the help that it desperately needs? This is one of the biggest challenges in treating brain conditions, and it's exactly where our story kicks off.
What we're talking about is something called the blood-brain barrier. You can literally think of it as a great wall, or maybe the world's toughest bouncer, standing guard to protect the brain from anything harmful. So this barrier is basically a super dense layer of cells that acts like a microfilter. It's incredibly picky about what it lets through. Now, this is fantastic for keeping out toxins and infections, but, it's so good at its job that it also blocks most medicines and even therapeutic cells from getting where they need to go.
And this is where we hit a wall, literally. It creates a major stalemate for really powerful treatments like stem cell therapy. Stem cells are amazing for repairing tissue in other parts of the body, but when it comes to the brain, they're too big. They can't get past the security at the front gate.
So if you can't get the whole repair crew through the door, what's the next best thing? You send in a tiny messenger with the instructions. And this is where we meet the hero of our story today, the amniotic-derived exosome. It's like a nano-sized key specifically designed to unlock the brain.
Okay, so what is an exosome? Think of them as little cargo pods that our cells naturally send out to talk to each other. They're like biological text messages packed with important instructions and supplies. And here's the key thing to remember. They aren't cells themselves. They're the delivery packages that cells release.
And here is the absolute game changer, their size. We're talking about 80 nanometers. To put that in perspective, that is thousands of times smaller than a single stem cell. This isn't just a minor detail. This incredible smallness is its entire superpower.
And boom, that is the breakthrough. Because they are so unbelievably tiny, these exosomes can slip right past the brain's security guards. They can pass through the blood-brain barrier, something larger cells and most drugs just can't do. This means they can deliver their precious cargo directly to the brain tissue that needs it.
All right, so the messengers are in. They've gotten past the gate. The big question now is, what exactly are they carrying inside that little repair capsule? What makes them so powerful?
It turns out they're packed with this incredible high-purity repair cocktail. Let's break it down. First, you've got something called neprilysin. Think of it as a specialized cleanup crew, an enzyme whose main job is to find and break down the amyloid beta plaques associated with Alzheimer's. Then you have bioactive peptides, which help protect the brain tissue. And finally, they're loaded with neurotrophic factors, which is like fertilizer for brain cells, helping them survive and rebuild vital connections.
What's so brilliant about this is that it's a coordinated mission. It's not just doing one thing, it's a whole three-part strategy working at once. First, it calms down the chronic inflammation that's so damaging to the brain. Second, it puts up a shield to protect the neurons that are still healthy. And third, it actively provides the tools to start rebuilding and rewiring those neural networks.
Now, all of this science sounds amazing, but what does it actually translate to for people dealing with these conditions day to day? Let's talk about the real-world impact.
For someone with Alzheimer's, the impact is incredibly direct. That neprilysin enzyme we talked about, the cleanup crew, gets to work clearing out that harmful amyloid plaque. And at the exact same time, the other factors in the exosome are helping to regenerate the very neural systems that are critical for memory and cognitive function.
Now, for Parkinson's, the focus shifts a bit to motor function. Here, that rich supply of neurotrophic factors helps rebuild the pathways that control movement. It also creates a healthier, less inflamed brain environment, which allows crucial neurotransmitters like dopamine to work more effectively. This directly helps improve motor skills.
And this is just incredible. For stroke survivors, especially those who were told they'd hit a plateau in their recovery, this is a beacon of hope. The data suggest a potential for up to 60% functional recovery in really crucial areas like motor control and the ability to speak. That is a life-changing number. But let's bring it back from the numbers, because this is about real life. It's about the things we take for granted. It's about regaining the simple ability to hold a cup of coffee, or being able to follow and join in on a family conversation, or just taking a single step with confidence again. That's what this really means.
Okay, with any revolutionary therapy, I know the first question on everyone's mind is, and should be, is it safe? So let's look at the evidence, because that's where trust is built.
The safety data here is incredibly reassuring, and it comes from layers of rigorous testing. Now, this is the most important part. Because exosomes are not living cells, they cannot divide or multiply. That means the risk of them forming a tumor is 0. That's huge. Plus, because they come from amniotic tissue, they have a natural immune privilege, which means the risk of the body rejecting them is very, very low. And further tests have found no adverse effects on things like genetic mutation or the cardiovascular system.
So, what does this actually look like for a patient who wants to explore this? Well, the entire process was designed from the ground up to be as simple and easy on the patient as possible.
The journey starts with a deep and thorough consultation with a specialist, just to make sure this is the right option for you. The treatment itself is really straightforward, usually just a simple IV drip. And get this, the whole thing takes only 30 to 60 minutes. You're in and out, with a minimal burden on you and your day.
So if you're going to remember one thing from all of this, let it be this. The nano size of exosomes is their superpower. It lets them sneak past the blood-brain barrier to deliver these powerful repair signals directly into the brain, getting into places that have been off-limits to so many other treatments for decades.
And that really just leaves us with this incredible question to think about. What does the future look like when we can move from just slowing down decline to actively repairing and maintaining the health of our brain? Imagine a world where we can tackle these conditions we once thought were irreversible.
This has been a presentation from the Japan Regenerative Medicine Attend Center. Contact them to learn more.